AB Calculus AB 8-2 office hours. These are the even solutions. Hopefully you already checked them, but here they are. You can pause the video so that you can check them all. So go ahead and do that. Pause the video. Check them if you need to. Lots of plus C's on here. Last one doesn't have one because you can actually find the C. Okay, assuming you guys have checked these, I'm going to go ahead and do these problems. So, $14 is the integral of 2 plus y squared squared. And so our strategy is, let's go ahead and multiply this out. Let's FOIL it. Now, if you need to, do it in your head, write it out, but this is going to be 4 plus 4y squared plus y to the fourth. I did that in my head. If you don't feel comfortable with that, I'm sure you work. Okay, so now when I integrate it, this is going to be 4y. Notice there's all y's here, so our answer is going to have y's. Plus 4y cubed over 3. Power roll, bump it up 1. Y to the fifth over 5 plus c. Probably write it a little nicer. We could say 4y plus, it's fine. You can leave it like that. You can say 4/3 y cubed plus 1/5 y to the fifth. There's maybe different ways you could write that. So that's 14. 16 is the integral of 1 plus x squared in parentheses 2 minus x in parentheses dx. We're going to integrate this, but we probably should multiply this all out. So that's going to be a 2 minus x plus 2x squared minus x cubed. I just FOILed that. So the answer is going to be 2x minus x squared over 2 plus 2x cubed over 3 minus x to the fourth over 4 plus c should show up now. We can maybe write this a little nicer. 2x minus 1/2 x squared plus 2/3 x cubed minus 1/4 x to the fourth. It's fine the other way too. It's not a big difference. If you pretty much wrote it the way I originally did, that's fine. Okay, that's 16. 18 is the integral of 1 minus 2t cubed over t cubed dt. And our strategy for the last couple days has been, let's distribute the division. This is 1 over t cubed minus 2. You might want to rewrite this so that it is t to the negative 3. So this is going to be power roll. You bump it up 1, divide by the new exponent, minus 2t plus c. Final answer, no negative exponents, negative 1 over 2t squared minus 2t plus c. Okay. 20 is the integral of 1 over 2t plus the square root of 2e to the t. The e to the t is not inside the square root. Square root of 2 is just a number. Now the mistake some people might make is rewriting this right here as 1/2 t to the negative 1. But that's going to cause problems because when you integrate it, you're going to get t to the 0 divided by 0. So what you need to recognize is this 1/2 natural log of the absolute value of t. The derivative natural log of t is 1 over t. And then you have the 2 in bonds is 1/2 in front. Minus the square root of 2, the antiderivative of e to the t is e to the t. Just multiply by the square root of 2 plus c. That's it. That's your answer. 22 is the integral of 4 secant squared x plus cosecant cotangent x. And this is about as direct as any of these problems get. The antiderivative of secant is tangent x, right? The antiderivative of cosecant cotan is cosecant, but it's going to give you an extra negative when you take derivative of it, so you need a negative here to cancel it out. Plus c, don't forget the plus c. 24 is the integral of secant x tangent x plus cosine x dx. I think it might be good to distribute this, and then you get secant tan, which is something we recognize. But then you get secant cosine, which is not something we recognize. So maybe this guy, we need to rewrite it as 1 over cosine times cosine. This is actually just 1. So when we integrate, the antiderivative of secant tan is secant. The antiderivative of 1 is just x plus c. Sometimes you got to work on these. Get them into something that is easy to integrate, right? Okay, 26 is the integral of dy over cosecant y. Well, isn't cosecant the same as 1 over sine? And we're dividing by it, so wouldn't we multiply by the reciprocal? And isn't this just sine y dy? It is. The antiderivative of sine is cosine with a negative, because the derivative of cosine gives you negative sine, which we don't want, plus c. Is that it? 28 is the integral of these weird Greek symbols. I forget what they are. Doesn't matter, but they should be in your answers. So I'm going to rewrite this as plus 2. 1 over sine squared would be cosecant squared, right? And the antiderivative of this is going to be that squared over 2. And then this is going to be 2 cotangent. But a negative, if you take derivative of this, it gives you negative 2 cosecant squared. So I need an extra negative to make it positive, plus c. That's it. 30. 30 is the integral of sine 2x over cosine x. Now this one's a little tricky because you got to use your trig identities for double angle. The double angle identity for sine 2x, you guys have learned this in previous math classes, is 2 sine x cosine x. So I just replace this with this because they're equivalent. And when you do that, the cosines go away. And so we get 2. Antiderivative of sine is cosine x. Need a negative in front though, plus c. All right. So that was a little tricky. Okay, got a couple others. 39 says, suppose that a point moves along a curve y equals fx in the xy plane in such a way that at each point xy on the curve, the tangent line has a slope of, so tangent line has a slope of negative sine x. Find an equation for the curve given that it passes through the point 0, 2. So this is the slope, right? Which is the derivative of the curve. They're giving you the derivative of the curve. So if you want the original function and you have the derivative, you integrate the derivative, right? So we need to integrate negative sine x. Now, what we get is we get cosine x. It gives you negative, right? Plus c, but we don't want the plus c. We have an initial condition right here. This is your x, this is your y. So if you plug in 0, you should get 2. Cosine 0 is 1. So you're going to subtract 1 from both sides, and c equals 1. So your final answer for the function is fx, or y equals cosine x plus 1. All right? Okay, 40 says, suppose that a point moves along a curve y equals fx and xy plane in such a way that at each point xy on the curve, the tangent line has a slope of x plus 1 squared. Same idea. They're telling you that the tangent line has a slope of x plus 1 squared. So this is your slope. This is your derivative, right? They're giving you the derivative. They tell you that it also passes through the point negative 2, 8. So that's going to be your initial condition. So you can find your c value, right? That's what that's for. So if you want the original function, this is the derivative. We have to integrate the derivative, which is x plus 1 squared. Now, the way we're going to do that is we're going to FOIL that out, x squared plus 2x plus 1. That's what we've been doing, okay? So what we're going to get is we're going to get x cubed over 3, bump it up 1, plus 2x squared over 2, those cancel out, plus x plus c. And now we're going to use that to find our plus c. So we're going to plug in negative 2. It's going to give you and it should come out to 8. So this is negative 8 thirds plus 4 minus 2, right? So it depends on how we want to deal with this. I mean, we could, this is 2, right? So we could subtract 2 from both sides if you want, and then we could add 8 thirds, right? And so C equals, that's going to be 6 plus 8 thirds. So we could make this, give a least common denominator, 3, 18, this is 26 thirds. That's your C value. So our final answer for the function is x cubed over 3 plus x squared plus x plus 26 thirds. So if they give you an initial condition, they give you any value on the curve, you can use that to find the C value. All right, a few more problems. Okay, 41 says solve the initial value problems, which means they're giving you a value that you can plug in to find the C value. So they're giving you the derivative, and they're giving you a value to plug in. So to get the original function, we have to integrate this. I'm going to rewrite it as 1/3 power. And so we get x to the 4 thirds divided by the new exponent multiplied by the reciprocal plus c. And then we're going to plug 1 in. And then it should equal 2. So we're going to subtract 3/4. That's what that's going to become. And so C equals 1 1/4, but we usually don't have mixed numbers, mixed fractions in our answers. That'd be 5/4. So your final answer is yx or fx or whatever equals 3/4 x to the 4 thirds plus 5/4. Okay. 43. Oh, that's actually part A. Part A. So here's part B. Part B is dy dt equals sine t plus 1. So we're going to integrate that. And then also we were given an initial condition of if you plug in pi over 3, you get 1/2 out. That's your initial condition to find the C value. So y equals negative cosine t, be careful of the negative, plus t plus c. So now we're going to plug pi over 3 in. It should give you 1/2. Now cosine of pi over 3 is 1/2, right? It's going to be negative, so you're going to add 1/2 to both sides, right? But then you're also subtract pi over 3. So C equals 1 minus pi over 3. That's your C. That's your C value. So x equals negative cosine pi over 3. Or sorry, not pi over 3. T plus t plus 1 minus pi over 3. Okay. Sorry, that's on a bit, and you guys couldn't see it for a little while. So I guess pause it and take a look. All right, C dy dx equals the integral of x plus 1 over, or they're giving you dy dx, and then we're going to integrate both sides. Right? They're giving you y1 equals 0. Now, I'm going to rewrite this as x to the first, and we're dividing, so rules of x, x to the negative 1/2 plus, well, actually, x to the positive 1/2. And then this one's going to be x to the negative 1/2 if I distribute the division. And so then that's going to be x to the 3/2 divided by the new exponent multiplied by the reciprocal plus x to the 1/2 divided by the new exponent multiplied by the reciprocal plus c. So then we're going to plug 1 into this. And those are just going to be 1s, right? And should come out to 0. So c equals negative 2 2/3, negative 6, negative 8/3. Right? So your final answer for yx equals 2/3, x to the 3/2 plus 2 square root of x if you want, or x to the 1/2 minus 8/3. Okay. All right, so that was 41, parts A, B, and C. 43, part A. Is dy dx equals 4e to the x, and y0 equals 1. So we're going to integrate both sides to get y. Now that's going to be 4e to the x plus c. That's an easy one. Then we plug 0 in, and it should equal 1. E to 0 is 1 times 4. So we're going to subtract 4 from both sides. C equals negative 3. So yx equals 4e to the x minus 3. Right? So that's part A. Part B is dy dt equals 1 over t. Y negative 1 equals 5. We're going to integrate both sides. This is the one that's the natural log. Natural log of the absolute value of t. You need the absolute values. Okay? We're going to plug negative 1 in, which that absolute value is going to make a difference. Okay? Because natural log of negative 1 doesn't exist. Natural log of positive 1 is 0. What do you raise e to get 1? 0. So c equals 5. So your answer is yt, I guess, in this problem, equals natural log of the absolute value of t plus 5. You need that. You need those absolute values. You lose points over that. Okay, next problem is 45. Okay, it says 45 says find the general form of the function whose second derivative. So they're giving you the second derivative. They want you to find the general form. That probably means with a plus c. It says hint, solve the equation f double prime x equals the square root of x for fx by integrating both sides twice. So, I mean, they're giving the second derivative. We did one in class like this. You got to integrate twice. So if we integrate once, we get the derivative. And this is going to be the same thing as x to the 1/2 dx. So you're going to bump it up 1 and divide by the new exponent, multiply by the reciprocal, plus c. Now this time we can't find the c value, so it might be helpful to put a little subscript 1 there, because there's going to be another c on the next step, and they are different c's. So we're going to integrate again, and we have 2/3 already, so we're going to get x to the 5/2 divided by the new exponent, multiplied by the reciprocal, plus the c from the previous one gets multiplied by an x, plus another c, which I'm going to call c sub 2. So our final answer will be 4/15 x to the 5/2 plus c sub 1x plus c sub 2 And that's it. 47 is going to be at each point x, the curve of the slope is, so they're giving you the derivative, y prime or f prime, whatever, for a curve. So if the curve passes through the point -3, 0, and we're going to try and find the answer. So we've already done a couple like this. This is initial condition problem. So we're going to integrate both sides. And we get 2x squared over 2 plus x plus c. You can use initial condition, plug -3 in. So it's going to be -3 squared plus -3 plus c equals 0. So that's going to be positive 9 minus 3 plus c equals 0. So that's going to be 6 plus c equals 0. So c equals -6. And so our final answer is going to be yx equals x squared plus x minus 6. All right. Let's see, 49. Says that each point x, y, the curve satisfies the condition. They're giving a second derivative this time. Second derivative. And it says the line y equals 5 minus 3x is tangent to the curve at x equals 1. So somehow we got to use this stuff probably to help us. This tangent line is probably going to help us figure out some stuff. So we're going to integrate once, and that's going to be 6x squared over 2 plus c. Now, this is the derivative. This is the first derivative. Anything about this tangent line that could help us? Isn't this saying that if the slope of the tangent line is -3, isn't that the slope of the curve? Isn't y prime at 1 going to equal -3? That slope is also the slope of our curve at this point. So we can use that as initial condition to find the c for the derivative. So it's going to be, we're going to plug 1 in, plus c equals -3. So c is going to equal -6. So for our derivative, we're halfway there, 3x squared minus 6. So we're halfway there. So we got to do it again. We got to integrate again. Y equals 3, bump it up 1, divide by the new exponent, minus 6x plus c. This is a different c. And somehow we might have the information we need to find it. This is the equation of the tangent line. And don't, if you have a curve and you have a tangent line, we've talked about this before, they share a point and they share a slope. Now, we already used the slope that they share, but now we can use the point that they share. If you plug 1 in, because they told us this was at x equals 1, you plug 1 in to the equation of the line, the point on the line is 2. So the coordinates of this point are 1, 2. Now, this point on the line is also a point on the curve. So that's another initial condition that we can now use in the original curve, the original line. Plug 1 in, and it should give us 2. That's going to be -5. So that's going to give you c equals 7. It's a different c, right? So your final answer is going to be y equals x cubed minus 6x plus 7. So this is a tough problem, but I guarantee I'm going to give you a problem like this on your next test, okay? And you're probably going to see this problem come up more times again. But I'm giving the initial conditions, but I'm hiding them in some other information, like about a tangent line. But you can use the tangent line to give you some information about the curve that it's tangent to. All right. So that's it for this assignment.